Yeah, hello guys. We are here back. Yes, on this class about Cozmo robot. So we missed last week class because several issues and many issues also for this week class, but we are here and we are going to do our best. So welcome everyone here and seeing and watching the chat channel, the people that is attending and saying hi. So hello to Cheryl that is there, Haro Stanko, hello, Danny Das, Menting, hello, and also Scamiambas that is here, Black Wing, Andreas Binder, Gloria from Palo Alto, very good, and many more that I can see there that you are watching this live class, and I'm happy that you are there, but please, feel free to say hi, to say whatever. Remember that we have this chat beside the video and that you can use it for sending the questions during the whole live class or even at the end, but you don't have to wait until the end, okay? So feel free to say whatever. This is a live class, it's a collaboration between you and us here, and let's make it fun and let's make it that we learn a lot all together. I see here more people saying hi, like Ritik Kumar, Comrade Cisco. I see, Comrade Cisco, that you have been asking some questions on the other videos that we have in our YouTube channel. I will answer some of them later, okay? So I think I answered some of them, but you still put a lot of questions, and we are on the duty of doing this. There is Sean Hanley, hi. Linda Capito, of course, hello, Linda. And Nick Carter also, hello, Nick. Okay, so very good. And for all the others, hello to everyone. Let's go straight to the work of today. And today what we are going to do is to use the Cozmo robot simulation to make that robot to detect one cube that is there that has a pattern on it. And then we'll make we'll see how to make a detector for that using ROS, and then use the information from the detector to make the robot to approach that cube. Okay, so that's at the present, the current state. Okay, so today it's an easy, even it may look a little bit difficult, it's an easy class because most of the things are already done. So don't worry if you think that this is going to be too much. Don't worry about that because you are going to follow for sure. And then another thing is that how are we going to do that? Well, as always, we are going to use a ROSject. Remember, a ROSject is a ROS project that contains the simulations, the code, the notebook, data set, everything together inside the package that you can open and then have the same experience that I'm having here. So I'm going to share the ROSject I have prepared for this live class with you right now, and then you're going to open it in your machine. Doesn't matter if it is Linux, Windows, Mac. You're going to open it and then follow the instructions with me, okay? So remember, you don't need to install anything. You only need a web browser, the one that you are using now for the live class. So let's go. I think it's clear. I have to repeat this because many live classes, we get new people coming, and then so they don't know what is happening. So I'm sorry for the people there that already have attended to other live classes and already know that. But think about that like when we are in the plane, you know, and the hostess is explaining about the security procedures. So let's go. Security procedures finished. Let's go. So now what I'm going to do is to share with you the ROSject for today, okay? So let me connect with my screen, and then you are going to see what do I have here. So I'm connecting now. You can see my screen, and here is the ROS Development Studio. That is the environment that we are going to use for this live class. Of course, you need to have a free account there in order to follow. If you don't have, don't worry, because it will ask you to create one now when you get the ROSject. This is the ROSject for this live of today, and I'm going to share it with you. So click in here, and here I have the link for that. And I'm going to put this link into the video. Let me see which window it is here. Yeah, so into the chat, you got it there. So there on the chat, you can see the link for the ROSject of today. Just click into the link, and then you will get a copy of all the material that we are going to use today. And let me repeat that. Doesn't matter which type of computer you have, doesn't matter the installation. The only thing that you need is a web browser like Chrome or Firefox. And even Safari, it works. But at present, we only officially support Firefox and Chrome. Today, I'm going to use Safari anyway, so don't worry. Then, yeah, so click on there and let me know if you have any problems. So I'm going to follow from now, from assuming that you have copied this ROSject. Yes? I see here Commander Cisco says, please, thanks, I look forward for your help. Yes, so Commander Cisco, I will answer you. Then let's continue then. I see that everybody is more or less following. So we have to go here. Then here you can see that they have several ROSjects, okay? Many of those are related to previous live classes that you have attended probably, or maybe there are some other ROSjects for other projects that I am doing. So that's it. The one that we are going to do today is this one. Remember that you can always come here to the public ROSjects link and search for other ROSjects that somebody else has done. Here you can see that there are more than 2,800 public ROSjects. So have a look. You can also search here for specific commands, like for example, ROSbot. If you search for ROSbot, you will see ROSjects related to the ROSbot from Usarion robot. So yeah, so have a look. But today I'm going to my ROSjects, and I'm going to open the 48 that I have already shared with you. And then if you are in my same situation as me, the only thing that you need to do is to click here on Open ROSject. Then after a while, then I'm not going to restore the workspace. I'm going to say no, because I want to start from a fresh desktop on this. And now after a few seconds, I get my notebook. This is the notebook that is included into the ROSject. And this is material that the team of the construct we have prepared for the live class. Okay, so that's the material that we are going to follow today. And let's go. I hope that all of you are having the same experience as me. So you have opened the ROSject, and then you have automatically got the notebook open. In case that you don't, for whatever the reason, or you can close it here. In case that you want to open again, just go to Tools and then press Jupyter Notebook, and then you will see a selection. So let me show you very, very quickly. It's so if I close here, then I go here to Jupyter Notebook, and then I got it again. Well, actually, I will have to select the files. I can have several notebooks. In this case, we only have the live class. Then I select that one, and I am in. Okay, so let me check very quickly if everybody is okay. So I see here Robotics Advanced Study that says hi, but nobody's asking anything. So I presume that everybody is working and on business. Very good, very good. So let's go. As I mentioned, let's make the Cozmo detect its cube. So from the previous live class, we have created a simulation of Cozmo. And then on the next live class that we did, the 47, then we created an environment for Cozmo that is a desktop with some books and also containing the cubes. The cubes are some toys for Cozmo that the creators of Cozmo have created. So in order to allow Cozmo to play with something, and we included that in the previous live class. All that material, the simulation of Cozmo, and the desktop, it's included already here in this ROS Developers Live class. So you have, where do you have? Hey, I want to see the simulation. I want to see the robot. I want to see the code. Okay, very easy. Go to Tools and then IDE. Select IDE. So you're going to see all the files that we have created related to this simulation and its environment. And we are going to go step by step, okay? So this is just a preview, let's say. Let me close all that because I was working with this. Then here you have different workspaces, Catkin workspace, data sets, notebook. Then inside the notebook is where you have the Jupyter notebook that you have open here, okay, with the images and everything. And inside here, the simulation /source, here you have all the packages that we have created for Cozmo. It's called Cozmo simulation. And then it contains two packages, basically, the Cozmo description and the Cozmo Gazebo. Okay? And we are going to move around here during this lesson. Well, actually, very little, because most of the things here we have already done in the previous classes. So on the first class, on 46, we created this Cozmo description, which contains the model of the Cozmo. And then on another class, on the 47, we created the wall here, the wall that we are going to use today, as well as the models with the books, with the cube, and with the desktop. Okay? So far, so good. So now let's go about this class. We are going to use the camera of the Cozmo robot to detect the cube using AR tags. We are going to see what are AR tags. And then we are going to move the robot towards the detected cube. That's it. And the whole project here, the whole files that you got with this live class, we call a ROSject. Okay? You can create your own ROSject and share with the people. You can use it for your classes, for your students, for your research, for whatever that you need to create code for robots. And also you can include the simulations for testing or the documentation like you are seeing here. Well, anyway, let's start here today by launching the robot playground. Let me put it here. This is the space that we are going to use today for the class of today. And then in order to launch it, let's go to simulations, select the launch file, and then main launch. Go to simulations, select launch file. And then here on this pop-up, you can press on this white space. You can press and then select the main launch file. This is the one that is going to launch this scenario, the playground for the Cozmo robot, and then press launch. By doing this, a new window will appear, and we are going to see here this environment that I have already set here in a few seconds. In the meantime, let me do one thing. So you know that, I mean, this is very small because I'm using a laptop for transmitting here, so too many things on the same window. What I'm going to do is to detach the IDE from this desktop and put it into a new tab. How do I do that? Very easy. I press this icon here of the IDE. You see the IDE is this window here, and we are going to use it for seeing the code or things that are related to all the models and the worlds, etc. So if I press this button here, it will create a new copy of that IDE here in another tab. So that is very convenient because then I can remove this one from here. So I have the things a little bit more organized. So let me put it here, for example. I can put only the simulation. And then on the other tab, you can see the IDE. Yeah? Okay, so here we have the simulation. Let me hide the logs of the simulation and move a little bit better in order to see the space. So here we have the cube, one of the cubes. I have hidden the other cubes, but you can add later if you want. You go to the wall that we are launching, and then you can add the other cubes. At present, I have put only one just to simplify the things. Okay, so here is the cube, and it contains a pattern here that you can see the pattern. That's what we call an AR tag. Okay, so that's the pattern that we are going to use to identify the cube. So the robot will use this pattern that is distributed along all the faces of the robot, of the cube. It will use that for identifying this cube as with an ID. So how do we do that? Before that, let me go to the to the chat and see if everything is working. Then I see, let me see, many comments here. Then we have Pei Subab that says, hi, hello. Pei Sean Hanley was loading for a long time. Now 404ing. I mean now. Okay, so if you get a 404 in this, then you can press one button that is here. Let me see. Let me show you this button here to refresh the scene. This button, sometimes there are delays, sometimes there are problems in connection. So we have added this button, this icon here to any window that allow you to refresh the screen. So if you press, then it will refresh the content, and then it will create the new connection that is required for whatever the reason that there was a problem in the network or a delay or something. So if you get that, please try that button, and then you will, this 404 will be missed, will be removed. Then Nick says, video was also slow to load. Video, you mean video on YouTube or which video? I don't know. If it is video, then we can do nothing because this is directly transmitted from YouTube. Then Commander Cisco says, tools ID gives bad gateway. The same problem, please. If you get that, go to the tab here. Okay, so in this case, it's in another tab. Sorry, here when you are here on the desktop, and then press that button here, that icon, in order to refresh. Then Nick says, can I go through the online part later after watching this? I don't have an account set up. Yes, of course, Nick, you can afterwards because you already have the link. You already have copied the ROSject, so you only need to create the account, and then you will get the copy of this ROSject. Then this video is going to be published online on our YouTube channel, so you can come back later and watch the video and follow the instructions, and you will have all the material also on your side, on your account. Then Kashif says, hello Kashif. Please, Kashif, if you just arrived, click on the link of the ROSject to get the material for this live class. Then Commander Cisco, bad gateway issue fixed. Yeah, probably it was due to delays or things like that. We are trying to improve that. So in order to prevent those messages from appearing. Mudashir, hi. Ben Sharif, tutorials, hi. Hello, everyone. So let's continue. Let's continue here. Okay, we got it up to that point. So now let's, we have the scenario where we are going to move the robot, and let's go and let's spawn the robot. If you remember on the previous live class, when we created the environment, we already have created the Cozmo simulation, but there was a problem in the simulation that the Cozmo was created with very big dimensions. It was like the 2 meters Cozmo robot, and actually Cozmo is just a few centimeters size. So, so we have been working hard in order to transfer from those meters into centimeters, and it was not easy. Many problems. But finally, we got a working version. I don't say that it's definitive and that is 100% correct, but good enough to do this live class. In any case, remember that this Cozmo simulation, it's Git synchronized. So the Cozmo simulation is here on the IDE under simulation workspace, source, Cozmo simulation. Okay, so here, all this content is Git synchronized. So it means that your simulation, the one that you have in your area, is synchronized with our Git. So any modification that we do, you can pull it. You can pull it, and then in the future, when we improve this simulation, you can pull it and then get the final version, the current version that works even better. Remember that. And how do you do that? But very easy. Go to Tools, open a shell, a terminal, and then just go to the simulations workspace, then inside source. And here, if you do an ls, you will see Cozmo simulation, but you can also the git status, inside the Cozmo simulations, of course, git status. And yeah, so I have many modifications here that I have to push that I haven't pushed. Very, very in a hurry, so they are not there. But you can see this is a synchronization with the Git that contains the whole simulation. That means that any modification that I perform into this simulation, you can get it from wherever you are, from wherever your account you are. So that's beautiful. That works super cool. Okay, so we got the simulation here of the Cosmos. So then let's launch it. Let's spawn it into the space because we want it to work there. So for that, we need to launch this command. And yeah, for that, we need to open tools, a shell, as I mentioned now. I'm going to use the previous one because it's here. And I'm going to put it here and type the command. Remember, the command, you have it there on the notebook, is ROS launch Cozmo _ Gazebo space spawn tap Cosmo launch. And then if we do that, then Cosmos should appear here in our simulation. And yeah, okay, so it appeared here beneath the table. Okay, so that's something that we can solve very easily. And you can check then on the launch file and change the values for spawning the robot. Do it yourself later. But now, very easy, click on the robot. Click on the robot, and then click here on this icon with the cross of arrows, and then we can move the robot up. Let's move it up, a little bit, just a little bit, okay? Don't put it too much on top of the table, and then press this single arrow. Okay, there it is. We got Cosmo in our system, and just in front, well, giving the back to the to the cube. Okay, so in order to put it facing the cube, you can press this icon and then turn the robot on the other direction. There it is. And then press again the arrow, and there it is. Okay, so what can you see on this model? There we have a couple of problems here still. The one is that the camera, I put the camera, I was doing some tests, and then I put the camera outside the robot and still is there. So we should fix that. That's very simple. You go to the Cosmo robot model and use it. So you modify the joint position of the camera. Okay, so you do that, and then you will put it inside the head of the Cosmo. Okay, now it's here, is it on the outside? And yeah, I'm sorry, that's a mistake. Basically, it's a mistake of me. I didn't have the time to solve that. But you can do it yourself. So try it and let me know if you achieve that. Then another thing that we can see here is that the robot is kind of moving around, and yeah, I haven't identified why yet. But it's kind of sleeping in the environment. I don't know, because the motors, they are stopped. So I don't know why it's moving by itself. I don't know. And if you have any clue or you have any idea, please suggest that to me, and we'll try to fix it. But anyway, we have the robot, we have here the cube, and now let's go. And let me tell you a little bit more. How are we going to identify the cubes? For identifying the cubes, what I mentioned is that we are going to use the AR tags. So if you click on this link, you will get more information about the AR tags. Basically, are markers for that are fixed and that we can use for identification. Okay, so here is the definition. And in order to identify the AR tags, we are going to use a package in ROS that is already done. So we only have to configure it and launch it. And this is called the AR track Alvar. So that's a package. And oops, okay, so my link is not correct. This link is not correct. Yeah. So this should point to another AR track Alvar. So if we go here, should point to this location here. Yeah, here it is. Here it is. Let me share this with you on the chat. Here is the AR track Alvar. Here. And then there is here on the chat, there is people saying hello, Sandra, RZ, hello, new people, and then can turn Cozmo around, Commander Cisco. How? You cannot turn Cozmo around. I mean, it's very straightforward. Is you select the Cozmo, you have to click on Cozmo. Once it has been selected, you go here to this icon, then all those colors, circle colors, you can select one of those and then move it in one direction or another. Of course, you can use it another direction to move it, you see, depending on the color of the ring, of the circle that you are selecting, then the robot will move in one direction or another. Okay, so now it's pushing the cube. Let me move it backward a little bit more. Okay, so I hope that you can do it. Okay, so let's continue. Then here in the AR Track Alvar package, this is a very nice package because you can use it for creating tags that then this software can detect, and also can detect the location of the tag and also even the orientation of the tag. So that's very useful. If you can put those tags inside on top of the objects, then your robot will be able to detect those objects. So if you create a tag with an ID, and then you provide this ID to one specific object, let's say one ID for my iPhone, and then I put it on the back of the iPhone, then whenever the robot says that tag and recognizes it, then it will say, oh, that's the iPhone. So it's a way of simplifying object recognition, or even it could be for giving directions, for example, the exit, the I don't know, the toilet, and then the robot will be able to identify in which location it is in an easier way. So there are many, many applications for this. And here we are going to use this package. And basically what I have done is to create one tag for this specific cube. And how do you create one tag? It's very easy. It's with the package. Once it is installed, you launch this command here, and then you will get the tag generated. So let's do an example. If I go to Tools and then open a shell, then here I'm going to copy this command and launch it here. Sorry, didn't copy correctly. And here, okay, wait a second. I pressed the wrong keys because I'm on the Mac today. And then, yeah, I have to remove the first this dollar sign. Okay, so we got it, this command, and then if you launch it, then it's going to, oh, wait, it's not, because there is a parameter that is called the ID number. You see this ID number. So let me put it bigger like this. Then Control B here. Okay, so here we have the binary of the program, and then we have ID number. We have to change this ID number by one ID number. That's the ID number that we are going to use to identify one specific object. For example, my notebook. Then my notebook is going to have the 1, 2, 3, 4, 5, 6. Yeah. So that's the ID that I'm going to provide to my book. So whenever the robot identifies 1, 2, 3, 4, 5, 6 tag, then he is going to know that it's my book, or what, for example. Then afterwards, we have this parameter that is the size of the tag. This is very important. You have to provide a size that is correct. Otherwise, the recognition will not work properly. This is for 2 centimeters. This means 2 centimeters. And that's the size of the tag that we have put here on that cube. And let me move again the robot like this. And I leave it like this. Go there, play. Yeah. So that's a cube, and that the size of the area there is 2 centimeters. That's why I created like this. But then if you want to put the tag in something bigger, then you create the tag bigger, then you specify another another dimension. So if you do that, then the marker has been created. Marker data 1, 2, 3, 4, 5, 6. And then you can go afterwards to the IDE we have here on this tag. And let's go to the user. Here I have created this marker data 1, 2, 3, 4, 5, 6. Okay, don't open like that. Then if you right click, right click, and then you can say open with preview. So you can see here the tag that has been generated. Okay, so another way is that how to put it into this this cube here. So there is here, I have attached here a video. If you press on this cell of the YouTube video and then press play, you're going to see this video here that you can watch later that shows how to attach that tag that you have generated into Gazebo model. Okay, so that's what I have done. Okay, so far so good. Then what else? Now let's start the tag detector. Okay, so that's the program that this package is providing, the tag detector, and then it has some parameters that we need to specify, and which ones are here on the launch file. So I have created already this launch file for you, but I have reproduced it here in order to watch with you together all the parameters. Yeah. So let me put it bigger like this. Okay, let me check so far if everybody is following. Mohammed says, I missed the code. Can anyone send it to me? Yes, Mohammed, the link is above on the chat. Go a little bit up into the chat and then you will get the code there. Okay, so far so good. Then let's launch this code for detecting the tags. And this launch file is included inside the Cozmo Gazebo package. And it contains this code here. You can watch it here on the IDE. If you go to the simulations workspace, source, Cozmo simulation, Cozmo Gazebo, then launch, then AR track Cozmo. Then you open it and then you will get that code here. So you can use this for later for better for testing or for doing your own tests. And what do we have is basically those parameters are the marker size that has to be 2 centimeters because, as I explained to you, is the size of the marker. Then this is the marker error. So the marker error is how much error are you accepting? Actually, no, how much it's so the lower the value, the more error you will accept, the less confident result you will accept. So if you want to have very, very confident values, then you had to put here a big number. The max track error, I don't remember, what is this one? Okay, so that's the other way around. So it's once you have seen a tag, how much error are you going to consider before you see, okay, that one that I have identified is not anymore a tag. Then we have the camera image that is the topic that is generating the data from the camera. In this case, is for this camera that we have in the Cozmo. Cozmo, come here, please. Come back. Don't go play around. Stay here. Okay, so we have that camera, and the topic is called Cozmo camera image. Then we also have to provide the camera info topic. That's another one that is published by the Cozmo camera. It's publishing this. And then finally, we have the output frame. The output frame means the frame from which the data of distance and orientation is going to be published. So I have put, here it says camera link, but afterwards I change it into base link. So let me put base link now here. You can also change it. In the IDE, you can see that is base link. It's not a big deal, but it depends on from which location you want to have the data. So if you are specifying the base link, that means the center of the robot, then we can know better from my center, I mean from the center of the robot itself, where is located the tag. Okay, so from my center, in which direction do I have to go? Okay, that would be the most correct way of doing it. We can also put the camera link, of course, and then the direction will be given from the point of view of the camera. But it's more correct from the center of the robot. And then that's it. Then we just launch the node, and you should launch it like this, and we provide the parameters. That is all. We need to do a remap because this node, the node of this individual, the node is called individual markers no connect. This one is expecting the camera into a topic that is called camera image. But instead, so we provide this argument for changing the name of the camera image. Instead of camera image, we provide this other one, Cozmo camera image. That's why we do this remap. And the same for the information of the topic, of the camera info. That's why we are providing this remap here. I hope that that's understood. If not, please ask me if you don't understand the remap. Remap is a very stupid thing, but usually is very confusing for us because it's not very intuitive. So let me know. Then, so let's launch it. Let's go and launch it, see what happens. So let's launch this command. You can copy, open a new shell here and launch it. Remember that those shells, those things that you are launching, you can at any point in time detach from here and create a new tab. That's especially convenient if you have multiple monitors, because you can put every tab on every monitor, for example. Okay, so let me launch it and let's see if everything is working. Yeah, so up and running. So in theory, Cozmo is publishing in some topics. So how can we see that? Well, we are going to use RViz to see the detections. But before that, let me show you how to do it in the manual way very quickly. Go to Tools and open a new shell. Yeah, you know that ROS is always about shells and launching. And so we are making honor here to ROS behavior. So you launch here, and then if you do a ROS topic list, then you will see here a couple of topics. This is the visualization marker that is published by this program, the tracker of AR tags. And then another one is this one here, is called AR pose marker. This is being published, AR pose marker. This is published every time that the robot detects something. So if I do a ROS topic echo of that topic, AR pose marker, okay, I see nothing. So it looks like the robot is detecting nothing because it should be here where it says, let me Control C, it says markers. Here it should provide the position and orientation of the detected marker. That means that it is not detecting anything, but makes sense because it's not facing the actual cube. Okay, so let me move the robot again. Put it some way, maybe here, maybe here. Let me put it a little bit closer, and that's it. So now let's see. So I have stopped it here. Okay, so let me put it there, and still it's not detecting anything. Okay, so I don't know what is happening. Let me do one thing. Let me start RViz, and let's see if the camera is facing properly the cube. So for that, how do we do? ROS run RViz. So RViz has started, but we see nothing here. What is happening? Where is RViz? Don't panic. Don't panic. We have RViz in another window, of course. RViz is a new graphical window. We need to visualize in a different window. In order to see all the graphical windows that ROS is generating, you have to go to Tools and then open the graphical tools here. So if we open the graphical tools, we'll be able to see here, okay, so that's it. That's RViz, and we can see now that the robot is starting now to face the the cube, but now it misses again. Okay, so that's maybe it's not the problem. Okay, so that's why it's not detecting anything. I'm going to move away from the robot itself. And this is the camera, what the camera is watching from the camera of the robot, what is seen. So let me move the robot here and see if I can make it face better the cube. Okay, so now is the cube there. And I see nothing here. It should detect the cube, but it's not. Maybe it's too far for him. So let me move it better, because it should appear here a marker. For that, let me see if I publish, if I include it. Let me see here. Okay, no, the marker is not being published here. Yeah, okay. So what is happening is that this default configuration is not the proper one for visualizing the markers. So I have included another file, a ROSject configuration that will allow us to see when the robot is detecting one of the tags, and it will publish a pink marker here. So let me show you how to do it. And for that, I'm going to detach here. I'm going to detach from here and put it into another tab. Then when this happens, then you have to go here to the ROSject and close this window here, close it. Once I have detached here, now I can press again login. Okay, here it is. Then I'm doing this because I'm sure that you will see better now. Now, how do we load the new config file? Very easy. Go to File here of the RViz menu, go to File, and then say Open Config. Then you have to go to the directory where I have put this. Let me show you where it is. If we go to the IDE again, okay, I'm going to move slowly. Okay, I'm going to the IDE tab. Remember that I open it here. Okay, so here inside the Catkin workspace, if I open it, then inside source, I have included the config RViz. So that's the one that we need to open from RViz. So we have to say, hey, please RViz, open this config. And it is inside user, Catkin workspace, source. Okay, so let's go again back to the RViz tab. Then we have to go to user. So that's not the proper directory. I'm going up. Then I'm going to Catkin workspace, source, and here it is, the RViz. And I select open, I discard this one, and there it is. Okay, so here we start to see some things. Yeah, so we see the robot that is here. We also see the TF, and we see a marker that was detected around there. I don't know what is this, I don't know. And see here on the camera, we see nothing, of course. Of course, so let's go back to the simulation and let's move again the robot to the proper location. And I think that I got stuck in some way. Let me see. So yeah, so I'm going to refresh my simulation. So I'm going to press this icon here to refresh. And I got it there. Then let me put the robot, there it is. And let me move it a little bit here. Yes, somehow here. And also I'm going to rotate a little bit like this. Yeah, I'm putting it easy, okay? Yeah, because it's an example. So you can apply it later to more complicated things. So now it is, then you have, remember to press that icon in order to assess the changes, okay? Until you press that, until the changes are not executed. So I have it here. Then I can see that there is the marker is on the screen, and then here I see a detection that says, hey, marker there. Okay, no, not anymore. Not anymore. Let's see if we can achieve to get the robot to detect the tag. Let me put it there. And now change again. It's too low. It's too low. So I don't understand that. It's strange. Let me see. And if I put a little bit backwards, maybe we'll see better. And here it is. Oh, okay, okay. So there it is, a detection. Okay, so then let me show you. Let me move this. You can see that there is a detection, and now the detection has gone. Okay. Okay, so it's becoming a little bit tricky, and I don't know why it's so difficult. So let me see if I can put it back again a little bit. And there it is. And let's go back. So there it is, here it is the camera. It's turning, okay. So a little bit more. I'm going to rotate a little bit like this. Check back again. You know, that is robotics, how it goes. And I think it's too far in order to detect, but whenever it detects something, it has to appear a marker here together with a TF transform. There it is. Okay, so there it is. And as you can see here, we have the marker there that is there, and then the transform from the location of the base link. No, sorry, it's from the camera in this case. If you go to the topic, then you will see. You will see. Okay, so that's what it was supposed to do. The thing is that it has to be tuned to make it work better in better conditions, because the detection, it's very depending on the light. It's very depending on the size of the location of the configuration of the camera, of course. Then you can tune all those parameters in order to get better detections. Okay, so you can see now a detection situation, and sometimes it appears, sometimes not. It depends how the robot moves. And yeah, so that's the current state. Okay, but I'm sure that you got the idea. Before we continue, let me go to the chat and see if there are more questions. Then it says, Cisco RC, I will try again. I missed the code. Yeah, please explain remap again from Commander Cisco. Okay, I'm going to, before we finish. Then Cheryl, my RViz camera image seems to show Cozmo still on the floor. Okay, please repeat the RViz file location. Yeah, so Cheryl said it to you. So it's Kakin workspace/source. And the file is called config.bis. And Cheryl says that the RViz camera image seems to show Cozmo still on the floor. But I don't understand. Have you pushed the robot up? And then once you have pushed the robot up, Cheryl, you have to press that arrow button. Until you don't press that arrow button, that's what I mentioned, that the data of the simulation will not be updated on the new locations. So probably it's because of that you got that. Let me know if that's it. Okay, so you got some detections there. And now what remains? It's, well, that detection is very difficult because it's very small. Very small. So that is one of the problems that we have with the small Cozmo. And in order to make it work in better conditions, you need to tune a lot of things. Yeah, and you need to work and dedicate a lot of hours on that. So that's my homework for you, okay? So if you want to make it work better, go and tune it. Then once we have the tag detector, what we can do is to create a program that generates velocities. So the robot will move towards the cube. Okay, so that's the program, as simple as this, that I have created for that purpose. And it's very simple. Basically, what it does is to subscribe to the AR pose marker topic. That's one topic that I shown you before, that this package, the detection package, is publishing every time that there is a detection. So if you remember in one of those shells, not the one, not the one, not the one. Okay, so that's the one that is not used. So let me do a ROS topic echo of what's the name? It's called AR pose marker. AR pose marker. Then it's saying nothing. Okay, so this says markers is empty because it means that I'm not detecting. But you saw there, you saw here that there has been a detection. So at some point in time, the robot detects because of the movement, because of the lights, because of many things. So whenever it detects, it says, oh, here from that location, from base link, the position of the marker is at this location at X, Y, and Z, and with this orientation. Okay, so that's what this topic is publishing every time that there is a detection of the marker. Then what we do on this code is, oh, let's subscribe to that topic. And then when we subscribe, we execute the callback that is called getQ. Okay, so we got here, we come here to the getQ callback. And then here on the message, we contain all this information, of course, as you know from basics of ROS. Okay, so that would be this up to here. Up to here. No, up to here. Yeah. So that's a message that we are receiving. And then at some location, at the location of the message, let me put it here better. It's the marker. It's, okay, let me see. The message starts here. Sorry, I confused. The message starts here. So at the location of the message that is called markers, then inside markers is an array, okay? But in this case, we are only having one possible detection because we don't have multiple markers. So then always is going to be the 0 marker detected. Only one detection can be because only one marker in the scene. Then it says the markers, the number 0, then inside pose position, that means pose, then inside pose, inside pose position. Then we are getting these data here on the getQ callback. So inside Q, we are getting the X, Y, and Z of the marker that we have detected. Whenever there is a marker detected, okay? Whenever there is none, then there is nothing. It's just a point, an empty point where we get in Q. Okay, so that's the callback that is being generated. And is filling Q with the data of the position of the marker detected. Then if we continue on the code, here we have this loop that whatever it says, oh, sorry, here there is a problem, there is an error, instead of caret, then it has to say Q. And then again here, instead of caret, it has to say Q. So what it says is this is the main loop of the program. That main loop, what it does is it spins here until we press Control C or we close ROS. Then what it does is to generate a velocity command based on the Y location of the marker and the Z location of the marker. Okay, so remember the Y location of the marker, it's the distance to the front. Sorry, that's not correct. That should be the other way around. That should be X for, because it's the forward that goes the robot is the X. And then the Z, yeah, also has to be the Y. Because this linear X is the velocity to the front. That based on the, and Y is negative. I don't know what is there. Negative, it should not be negative. So, so many errors there. So the velocity that we want the robot to move forward is based on the distance in the X axis to the cube. And then the angular, the rotation, it has to be based on the Y direction of the cube. That in this case it has to be negative, yeah, because it, okay, let me see, it's positive, yeah. So in that case it has to be negative because it has to turn on the opposite sense of the axis. Exactly. Yes. So that's the, I think it's correct, yeah. Then so let me show you here with the axis, actually, with the axis. Not those axes, okay? So those axes are just for Gazebo for moving. Those are not the axes. The axes that you have to check are the ones here in the TF of the robot, based on the base link axis. So how do you do that? You can come here to the model, here to the robot model, and make it transparent, for example. Let's make it alpha. Let's put it 0.2. Then the robot is almost transparent, but still too many things. So let me remove all the TFs, frames here. Instead of showing all enabled, let me remove them and then just show the base link, the marker. Well, actually the marker is going to disappear at any point in time. Then the odometry, it's okay. And that's it. Yeah, so the base link, as you can see, the X is the red one here, the axis on the right one, and then the green one is on the left. So that is why when I turn, so if the marker is around here, then I have to turn positive. Okay, so when it's positive, when the Y is positive, then I have to turn positive. Yeah, so then it's now negative here. So we have to remove the negative here. Yeah. So that's it. Okay, so let me summarize again. So we subscribe to the marker and we get the data on that callback. We get the data of the location on the variable cube. And then in this while loop, we get the cube data from the X and the Y, and then we compute, we generate a velocity, a linear velocity to the front based on the X distance to the cube, and an angular velocity rotation based on the Y velocity. That's a very simple control to approach. And then finally, once we have this speed, we publish into the common bell topic. That's the publisher move, that is a publisher to the common bell topic of the robot. Okay, so we don't have time now to execute that, but what I recommend you is that you test this at home. It's so what you have to do is to go to the Catkin workspace here inside source. I have created a package that is called GoToCube. Okay, and then here inside the source, you should create the source of this Python file and put it there, and then launch it. Wait, this one. No, you don't have to launch with this one. You have to use a ROS run. Okay, ROS run, GoToCube, and the name of your source, and that's all. And that is all. And then the robot will move towards the detected cube when it has been detected, of course, when it has been detected. Otherwise, it will stop because the point X and Y will be 0. Okay, so when it's no detection, then the robot will stop because X and Y 0. Okay, so basically that's it for today. But before I go to the questions, I would like to request you that please, if you like the class, give us a like on the video. You know, on the video that you are watching now, there is a like, a thumbs up that you can hit there, and that will be very useful for us to understand if you are liking our classes or not. And also I would suggest you to subscribe to the channel. There is a subscription there, and press the bell. There is a bell for notifications, because we are publishing new videos every day, and they are related about this subject, about ROS and how to learn about ROS. And finally, if you want still to learn more, then we have an academy that is online, and that is an academy for learning ROS with many subjects. It's called the Robot Ignite Academy. And in this academy, we have created online courses that teaches you using the web browser, and you don't have to install anything. Everything is ready already for you to start working. We teach basic concepts like basics, topics, also more advanced like navigation or perception with ROS, everything with ROS. And also more advanced ones like ROS2. We have a course on ROS2 on domain randomization using fetch robot, and everything is ROS, okay? So we are going to use always, we are going to teach you always with ROS, how to do those things with robots and ROS. Even we have here a course that it's about ROSifying your own robot. So how you can create your own robot, your physical robot, and how you can include ROS. How do you make that robot to be controlled with ROS? That's the course that we have there. So have a look at, you have the link there. Many courses there. And now let me go to the questions and see if there are more questions. And I'm going to also to answer the one from the remap of, there was a question from, let me see, Commander Cisco that says about the remap. Okay, so the remap is a concept that when you create a program in ROS, maybe your program is expecting to get data to subscribe to some topics. Okay, so for example, in this case, the people who created the AR tags package, then they were expecting that when you use that, you provide a topic with a camera that is called camera, for example. But maybe your robot is producing the camera data in another topic that is called my robot camera. Then how can you connect those two? If your robot is producing the data in a topic that is called my robot camera, but the program that is going to use the camera data is expecting to have a topic that is called just camera, how do you connect those two? Well, the thing to note is when you launch this node that requires the information, you do a remap. And on the remap, you first indicate from which topic you are. It means I'm expecting to receive the data on the camera topic, and then to which topic you have to connect. That's the name of your actual camera data. So that's how you create a remap and why you create a remap. That's a little bit confusing. It always confuses the people, and also to me. I mean, until I understood that confused me a lot. But I hope it's okay. Then let me see if there are here many comments and questions. Let me see if I can address all of them. And Sean says that happened to me. Robot thinks on ground. I think something failed. Make sure everything is still running. I restarted the project. Okay, that's another, I don't know, maybe sometimes Gazebo crashes, just crashes because yes. And then when that happened, you only can do is a relaunch. That's it. So go to relaunch, again, do the main.launch, and then spawn the robot. And also I will give you as a homework, include the spawn of the robot inside the main launch. So the next time that you do a main launch, it will spawn the desktop, it will put all the elements and even the robot inside the simulation. So that's homework for you. It says, Gazebo has quit on me, it just say loading. Okay, I don't know. Commander Cisco, I don't know what you mean there. So in any case, if that happened, close the window and start it again. That's the typical advice for without more detail. So how does this relate to programming a real Cozmo? So that's a very good question, Nick. So this week, I'm going to interview a guy on the ROS Developers podcast, that he's the guy who has created the drivers of ROS for Cozmo. Okay, when we created all this code here for this live class, we tried to make it compatible to those drivers of these guys. At present, I cannot tell you 100% that is compatible. So, but I'm pretty sure that it is. So still we have to do some checks. I mean, this takes a lot of time, you know? So the thing is, there is a guy, Cozmo in the inside doesn't run ROS, Cozmo. So there is a guy outside the Cozmo, Anki company, that the one that created Cozmo. So there is a guy that is a ROS expert, and he has created some drivers to connect from ROS into the real Cozmo. Okay, so based on those drivers, we have created the simulation, and the interface in the simulation, it aims to be the same as this driver. So if you use in your Cozmo, you use the drivers of this guy, and you put the code that you have developed here, then in theory it should work. We haven't tested, okay? But let me know if you test what's happening and any problems, and then maybe we can help you on that. Then Danida says it's working. Very good. Thank you, Danny, for the feedback. Then Commander Cisco, I believe Cozmo is ROSable. Yes. Answer, yeah, probably was explained in earlier video. Yeah, it wasn't Nick. It wasn't explained. Just explain you right now. Then I didn't understand the camera info topic. What kind of info it specs? How do we generate this info? Yeah, that's the typical. When you create publish a camera in a ROS topic, you have to publish that topic. So all the drivers, they do publish that. So it's there. I don't know exactly which information. You just go do an echo of this info, and then you will see. Or go to the camera documentation in ROS, and then you will see what you should create in case that you have your own camera and you want to publish in there. But all the cameras that are supported are already publishing on that topic by default. Then Gloria says, thank you, Rick. Excellent workflow to this common simulation. Thank you, Gloria. Then Sean says, like it, subscribe it, considering the coursework when I have a little more time. Okay, no problems. I'm happy that you just like the class, and that's it. I'm just proposing, okay, as in case that you need extra knowledge. I think that our academy is the best place for that. Thanks again for sharing, Danidas. A quick question regarding our ROSDS itself. Can we use ROS bridge server and communicate from outside via WebSockets? I would like to test the web interface. Yeah, I think that, I don't remember if it was you or somebody else that asked me about that. In theory, that should be no problem at all. Should be no problem. So let me know more about the details of your project, and then we can do a test together and test it. But I think that there is no problem. You can connect from the ROSDS directly to the real robot. So directly, if you have a robot here, you can connect from your ROSDS to my robot. If I provide you with some IP address that this robot is on the internet. So then I don't think that there will be any problem using the WebSockets and the ROS bridge server. Commander, gracias, I understand, remap now. Okay, very good. Gloria, if you miss some of the basic ROS functionalities during this live workshop, I highly recommend the Robot Ignite Academy. Best ROS workshops I've done. Thank you very much, Gloria. Thank you very much. My pleasure, really. And guys, that's it's all for today. So sorry, it's already 10 minutes past from the hour, and I think you are doing very, very long this live class. And please try the things that I haven't shown you today, but you have everything, the material there. Please try at home and let me know if there is any problem. Put the comments below this video, the questions and the problems that you have, and then maybe if there is something that is big, then I will ask you to send me an email. But it's better if you can put it beneath, because then everybody can benefit, can take benefit. Okay, so thank you very much, everyone. We are going to stop here, and then we'll do another live class on the next week. And we are going to start with Cozmo because we have many problems, and still, as you have seen, still the thing is not going fluidly, and it requires a lot of work in order to polish this. So we are going to do a new live class. It's going to be presented tomorrow, but we still haven't decided. So I cannot tell you what is going to be next week, but for sure there's going to be. So I hope that to meet you all here next live class, and see you around. Remember, keep pushing your ROS learning, guys. Cheers.